Hey guys, lately I've noticed a lot of people getting interested in the Phob GCC project. Many of you are eager to give it a shot and build it yourselves. I've been preparing for this project for quite some time too. Since I don't have a GameCube on hand, and sourcing all the required parts from different websites can be a hassle with the possibility of missing out on some or not finding certain parts temporarily, I went through multiple rounds of selection and testing to find suitable alternatives that would still deliver optimal performance. Luckily, I managed to do it. Now, I'm here to share my journey and the process of making it with all of you. Before we dive into it, I want to give a big shout out to the author of the Phob GCC project. Their documentation is incredibly detailed and it has been super helpful for me. I followed their advice and placed an order for the PCB and 3D printed parts from Elecrow. They have a thorough testing process for all the boards they produce, so I don't have to worry about receiving a dud. I really appreciate the peace of mind that comes with that. In addition to the PCB and 3D printed parts, I've also gathered the other components mentioned in the documentation: magnets, joysticks, potentiometers, motor brackets, trigger paddles, motors, and the Z button. Now, I'm going to demonstrate how to assemble it all. The Z button I'm using has a satisfying click to it, and I really enjoy the tactile feel. First, I'll solder it onto the board, making sure to align it with the 4 holes on the inside. And remember, safety first when using the soldering iron. After soldering the Z button, we can proceed to solder the potentiometer. If you are not confident in maintaining stability while soldering the potentiometer, I recommend using the author's method of securing the potentiometer with adhesive tape before soldering. This will greatly reduce the risk of injury or soldering issues. Next, connect the C joystick board to the main board using wires. When purchasing the wires, make sure to buy ones of good quality to avoid potential hidden issues. This step may take some time, but it's crucial to ensure that the solder joints are effective and reliable. Also, please make sure to tin both ends of each wire to ensure a smoother soldering process. Before assembling the joystick, we need to modify it by attaching a magnet to the 3D printed magnet mount. To ensure a more secure attachment, I used glue. Once the magnet is firmly fixed, we need to attach the entire magnet mount to the joystick. It's important to note that it should be fixed on the elliptical side rather than the circular side in order to properly secure the magnet mount. After securing it, remember to first move the joystick and check if the magnet mount is loose. If there is any movement, reinforce it further and consider using glue if necessary. Before soldering the joystick, pay attention to the orientation of the magnet mount. It must match the orientation of the 2 corresponding components on the board, otherwise the joystick will not function properly. During soldering, I only soldered the 2 smaller solder pads, and it does not cause any instability when using it. However, if you're concerned, you can choose to solder all 4 solder pads. The process of assembling the motor bracket is relatively simple, but remember to first attach the left and right trigger paddles and pay attention to the assembly steps. Then solder the left and right trigger paddles and the motor bracket will be considered assembled. Assembling the motor is even simpler. Just place it on the bracket and then solder it. Moreover, the solder pad for this is larger, making it very easy. Finally, when it comes to soldering the main cable, the most important aspect is the wire sequence. If you are using the default cable provided by GCC, you can refer to the example diagram provided by the author and solder according to the wire colors. If not, I would recommend using a multimeter to confirm the voltage of each wire before conducting the soldering test. The final step is to assemble the board with the casing I ordered, and it will be completed. Since I didn't use CrowVision, I didn't modify the casing. The assembly process of the board and the casing went smoothly, without any raised edges or gaps that couldn't be closed. After the assembly is completed, it is necessary to perform joystick calibration and button testing to ensure that all functions are working properly. Please do not skip this step, as otherwise, your joystick may not respond at all. This is one of the lessons I learned after spending a lot of time during the debugging process. I used a computer for the calibration, so I installed Dolphin Emulator and Smash Scope. The calibration process is simple but may take some time. However, it is worth it for the final result. Because I have already calibrated my controller before, once I connect it to the computer, the joystick can be moved. However, if you haven't calibrated it yet, your joystick won't respond. You can find the calibration tutorial in the author's documentation, which is very helpful. I appreciate the authors of the tutorial videos. After completing the controller, I started wondering if it would work smoothly on a Raspberry Pi. To test it out, I prepared a Raspberry Pi 4B, an SD card with the Recalbox image, and CrowVision for display. If it succeeds, could I turn it into a portable handheld gaming device? It's an interesting idea. Let's find out if it's feasible. Join me to explore. After powering on, the buttons on the controller can be used normally. I'm so excited. Moreover, we can manually configure the buttons, and the joystick can also be detected. I think we have already achieved half of the success. Next, I'm going to start a game and see how it feels to use it. So this is how it feels to play games with a controller. It's amazing. I had never used a controller before, so I always thought the keyboard was the ultimate gaming controller. It has so many keys, and when combined with a mouse, it can handle any game. But I was wrong. Now I realize that the controller is the way to go. It makes games come alive, and it's so much more portable. I can take my unique custom-made controller with me wherever I go. If I have the time, I'd love to modify CrowVision and Phob GCC, give them a new casing, and turn them into a truly portable and cool gaming device. At the end of the video, I have some good news for you. If you're interested in creating a cool controller yourself, you can follow Elecrow's website. Elecrow will soon be offering a complete set of materials required to make Phob GCC, so you won't have to worry about gathering all the materials or making mistakes with the wrong components. Alright, that's the end of the video. If you enjoyed it, please subscribe to my channel. Thank you very much for watching.